Hello, good to have you here. I love to tutor. Um, this question is on page 196 of New General Mathematics by MF Macrae et al. So the question says, find the value of x in each part of figure 19.18. Hence, state which type of which type of triangle each is. So we have two triangles here, and we're told to find the values of x in each of the diagrams. So we're going to take them one after the other. So let's take angle A. Looking at this, we have three angles, and we know that the sum of angles in a triangle is 180 degrees. So let's start with triangle A. So this angle is, we just add up the angles, 55. Sorry about that. 55 55 plus x degrees. This is one of its angles, plus 75 minus x. Okay, 75 degrees. And 75 plus 2x. 2x should give us 180 degrees. Reason, sum of angles in a triangle. So you can write that down so that we have, moving the brackets, we have 55 plus x plus 75 degrees minus x plus 2x equals 180 degrees. So we'll bring the like terms together. So we have 55 and 75 as ordinary numbers, and 55 plus 75 is 130 degrees. 55 degrees plus 75 degrees will give you 130 degrees. So we have 130 degrees plus x minus x will be gone, and we'll be left with 2x, which is still, everything is still equal to 180 degrees. So we have 2x, 180 degrees minus 130 degrees, and we have that 2x is equal to 50 degrees. And so dividing both sides by 2, we have that x, 2 goes here, and we have 50 divided by 50 degrees divided by 2 will give us 25 degrees. So our x for this for triangle A is 25 degrees. So if we have our x to be 25 degrees, we will need to impute the values of x in the triangle so we can know which type of triangle A is. So we have our x for triangle A to be 25 degrees. So we say 55 plus x is 25. 55 plus 25 will give you 80. So this is 80 degrees. And then 75 minus 25 will give you 50 degrees. So we have that this is equal to 50 degrees. And then we have 2 times our x is 25, 2 times x is what? So this implies that this is 50 degrees. So now, looking at this triangle, this triangle is 80, sorry, this angle is 80 degrees, this angle is 50 degrees, this angle is 50 degrees. Does it tell you the type of triangle it is? It's an isosceles triangle. An isosceles triangle is a triangle that has each base, that whose base angles are equal. So this angle is 50 degrees and this angle is 50 degrees. So that implies that this triangle is an isosceles triangle. So we can just write it under it that it's an isosceles triangle. Reason, because the base angles are equal. It has two angles that are equal. So now we move on to the next triangle, triangle B. Triangle B. So some of angles in a triangle is always 180 degrees. So we have the angles here are 3x plus 2x plus x plus 54 degrees. Okay. Okay, so for triangle, let's do that again. 3x plus 2x plus x plus 54 degrees is equal to 180 degrees. So that we have 2x plus 2x will give you 5x plus another x, that will be 6x. 6x plus 54 degrees equals 180 degrees. So that you have 6x, subtracting 54 from both sides, it goes up here, and we have 180 degrees minus 54 degrees. So that you have 6x is equal to 180 minus 54 will give you 126. Okay, 126 degrees. 126 degrees, so that you have that x here, dividing both sides by 6 will leave our x standing here, so that this side becomes 126 degrees divided by 6, and this implies that our x is 21 degrees. Okay, 2x plus 2x's. Okay, let's be sure everything is accurate. 2x, 3x, 5x, 6x. Okay, so we have 21 degrees. And so, okay, let's impute the value of x into the triangle and see. Imputing the value of x into the triangle, since x is 21, since x is 21 degrees, we have that 3 times 21 will give us 3 times 21 will give us 21, 3 will give us 63. So we have that the whole of this is 63 degrees. Okay, I should write that with a different color. Okay, so you have that this angle, this particular angle is 63 degrees, and then 2 times 21 here will give you 42 degrees. So you have that this angle is 42 degrees, and this 54 plus 21 will give you 54 plus 21. You didn't. Okay, and I feel, and I feel. So, what should I start to do? Keeping the need, then the winner will. You may well. Okay. Alright, so since we've gotten our x to be 21 degrees, so imputing the values of x here, we have that this 3 times 21. Okay, so since we've gotten our x to be 21 degrees, imputing the value of x here, we'll have that 3x is 3 times 21 will give us 63. So this is 63 degrees. 63 degrees, and 2 times 21 will give us 42 degrees, and x plus 54, that's 21. 21 plus 54 will give us 75 degrees. 75 degrees. So looking at this triangle, what type of triangle it is it? Now none of the angles are equal, so this is a scalene triangle. A scalene triangle has none of its angles are equal. So this is a scalene triangle. So we can just write it that it's a scalene triangle. It's a scalene triangle. All right. Hello, good to have you here. I love to tutor. This question is on page 157 of Functional Mathematics for Senior Secondary Schools by T.M. Asiwo et al. So the question says in figure 10.10, line PQ is equal to line PR, which is also equal to line RS, and angle RPS is equal to 32 degrees. Find the value of angle QPR. Okay, so let's take a look at the diagram. Line PQ is equal to line PR, which is also equal to line RS. So now, and we're told to find angle QPR. Angle QPR. So the angle is located at P. So this is the angle we're looking for. This angle, that's what we're looking for. Now, okay, since QP, now looking at triangle QPR, these two sides are equal. So this implies that triangle QPR is an isosceles triangle. An isosceles triangle is a triangle that has two sides equal. And so this triangle PRS is also as an isosceles triangle, and these are the base angles. RPS is the base angle of this triangle RPS, and this RSP is also one of its base angles. So if this angle here is 32 degrees, it also implies, since line PR and line RS are equal, so it also implies that this angle is 32 degrees. Okay, so I think we have to write it that since PR, okay, line P, oh goodness me, so line PR is equal to line RS, therefore angle angle RPS is also equal to angle RSP, and angle RPS is already given as 32 degrees. Angle RPS is equal to 32 degrees. So, and since angle RPS is equal to RSP, so this also implies that angle RSP is equal to 32 degrees as well. So now recall that an exterior angle of a triangle is equal to two interior opposite angles. Now, if you look at this triangle PRS, you can see that this angle QRP, now QRP is referring to this place, QRP is this place, QRP. So, and it's an exterior angle, it's an exterior angle of this triangle PRS. So what it means is that angle RPS plus angle RSP will be equal to this exterior angle, to its exterior angle. So angle RPS plus angle RSP should be equal to angle QRP. Angle QRP. Now, reason is that an exterior angle of a triangle is equal to two interior opposite angles. So you have that RPS is 32 degrees. So 32 plus 32 degrees is what we'll have as QRP, and this is 64 degrees, and that is our angle QRP. So we have that angle QRP is 64 degrees. 64 degrees. I think we should just write it 64 degrees. So now let's look at this triangle, triangle QPR. The two sides are equal. The two sides QP and okay, let's call it PQ and PR are equal. So this implies that this triangle PQR is an isosceles triangle. So, and you know, for an isosceles triangle, the two base angles are equal. So if this place is 64, it also implies that this place is also 64 degrees. So we're just left with finding this angle. So that is angle QPR. So for this triangle PQR, we have two sides. The two sides are already known, so we'll just subtract these two sides from 180 degrees to get the unknown angle. So we have that our angle QPR plus 64 degrees plus 64 degrees is equal to 180 degrees. Sum of angles in a triangle. So you have that angle QPR plus 64 plus 64 should give us 128 degrees equals 180 degrees. So this will imply that angle QPR will be equal to 180 degrees minus 128 degrees. So our angle QPR is equal to 180 degrees minus 128 degrees will give us 7 minus 2 is 5, and we have 52 degrees. So we found our angle QPR.